We can use the properties or characteristics of triangles to work out the size of missing angles. In this particular triangle, we need to find the value of this pronumeral y and give a reason or give reasons why we have that particular value. The first thing to notice is that it is an isosceles triangle because this side is the same as this one. So the reason we need to write down is that the third angle is also y degrees, and the reason we put here is that the base angles of an isosceles triangle are equal. You'll notice I use the abbreviation of a triangle here instead of writing the word out. So as long as you do it neatly, you can do that. So let's have a look and see what we've got. We can say therefore that this angle here is also y. So what we have is 28 degrees plus y degrees plus y degrees, all adding up to 180 degrees, which is the angle sum of a triangle. So in our algebra we've learnt that we can collect like terms. So let's do that. We've got 28 plus 1y and 1y is 2y, and all of this equals 180 degrees. Now you've learned how to do what we call two-step equations. That is, we're going to remove the 28 from this side by subtracting 28 from both sides. So it's 28, take 28, plus 2y equals, and because it's an equation, we need to subtract 28 from both sides to keep the equation balanced. We're left with 2y equals 152. And then finally, to get y on its own, we remember that this is 2 times y, so we can divide both sides by 2. These will cancel out. That's 1 and 1 here because 2 goes into 2 once, and so here as well. And we get y is equal to 152 divided by 2, which is 76 degrees. And there's our solution. In this example, we know that z must be equal to 2.5 centimetres. And the reason for this is that the sides are all equal. And I guess we need to say why, because it is an equilateral triangle. Now we know this because the angles of an equilateral triangle are all equal, and they all equal 60 degrees. So we now know that Z is 2.5 centimetres, and so is this side over here. So we can actually mark all these in as being equal. In our next example, we can see that x must be equal to 7 centimetres. Why is that the case? Well, we can see that this angle here is equal to this angle here. And we know that this must be an isosceles triangle. Isosceles triangles have the base angles equal. Now the reason why these are base angles is because they're together, and if we turn it around it would sit on them. That means that this and this, these are the equal sides. So if we turn it around like this, These are our base angles down here. So it doesn't really matter which orientation we have, as long as you recognise that where the sides are equal, the angles below them as such, these are the base angles. So that's the reason why x must be equal to 7 centimetres. In this triangle, we notice that all the sides are equal. Therefore, we know that n must be equal to 60 degrees. And the reason? The angles of an equilateral triangle, which we've got, equal 60 degrees. They all equal 60, as we know. So we knew that it was an equilateral triangle because each of the sides was equal. The markings told us this.